Hello, and thanks for joining me. Well, after the upcoming video, there's going to be some special announcements, and you might be interested. You never know. So don't fast forward at the end of the video. Stick with me, and let's get on to building this weld positioner. Hello, and thanks for joining me. Well, today we're going to build a weld positioner, like a turntable for welding around things. I'm making the platter now, and I'm going to bore a 1-inch hole in it, and then I'll show you how the rest of it's going to go together. Okay, I need to go 43 more thousandths. I'm going to speed this up, take it out of back gear. Okay, this 1.25 inch stock, this is going to be, I'm going to cut a ledge on that and weld that to that. That's going to be our turntable. Okay, I got this set up in my mill here, and I'm going to cut a tang on this. I'm going to make it 1/4 inch wide and a 1/2 inch tall. So I need to take a 1/4 inch off of this side. This is my drive motor. I gotta turn that down, put that on there, and cut a slot in there, and it'll mesh with that. And this will turn it. This will go inside this. This is a piece of phenolic, non-conductive and heat resistant. Then I'm going to turn the end of this down to fit in there, weld it, face that, and then drill a hole in here. Put that in there. And the reason I'm doing that is that way I can take the turntable off if I want to and mount things to it. I'll put a couple of series of rings on here to center things. I think it's going to work out good. It's a really small motor, but it really doesn't need much power. This is 2 RPM. The other day I was welding something 1 inch in diameter, and it needed to be 0.45 RPM, or no, 0.75 RPM. So it was less than 1 RPM to get a good constant weld around there. So I think 2 RPM slowed down with this pulse width modulation. It's a 12-volt motor. I think it'll work out good. So next thing I'm going to do is, I want this to end up about flush with that. Well, that's about a 1/4 inch there. That'll work good. I just need to cut a ledge on that fits in that right there. I think that's a press fit, which is ideal. Oh, I like it. I wish I'd ground that off before I pressed it in there, but. Well, I wish I had a weld positioner. It'd help me weld this. A hard time seeing that. Okay, it doesn't look too pretty, but it'll clean up nicely on the lathe. I think part of the problem was paint on there. Well, it's cooled off now. Let's see how straight we got this weld. I didn't tack it in 3 places before I welded it, which I should have. But it was a press fit, and the press fit might have held it, and that's why I wanted it a press fit. Oh boy, that looks great. I like it. I like it. I think I'm going to leave it right there. Still a little weld showing, but that's all right. Well, I think I got a good fit. It got real tight, I can't get it out of there. Okay, let's cut a 1/4 inch slot in this. No idea what speed. Perfect, perfect, perfect. Well, not exactly fine woodworking, but this motor here is slightly higher than the gearbox, and I had to relieve for that. And I think it did well. Perfect. A little bit of slop won't hurt anything, and it holds the motor captive. It's exactly what I wanted it to do. What I got to do is drill some holes there, put some wood screws in, and do all the electronics. And the reason I milled this out right here, make sure you can see that. The reason I milled this out right here, and I should have put a hole in line with, or at least a scribe mark in line, is I thought about putting an arm on the top, or one that I could bolt on, that would hold down on center. It could be useful. I need to cut some, drill a hole, put a bolt in there, a 1/4 20 bolt, in case I want to bolt something to it. Make some rings on there, put 4 holes in there, or 3 holes, with sliding jaws. And need to mount this potentiometer where I can get to it easy enough. 2 RPM motor, I believe that's going to work good. Well, before I go any further with the electrical on this, let's make sure it works. Make sure the arc doesn't somehow destroy the electronics. It's possible. Wow, I like that. Okay, I've got a double pole, double throw switch. So if I wire if you look at it closely there, I don't know if you can see that, it's got wires in an X. Switch it one way, puts the current to here. Switch it the other way, and it puts it over to this terminal via these wires. It doesn't have an off position. I didn't have the right switch, so we're just it's gonna be two directional. Okay, now the power wires. I would have preferred to have a little plug that I could just remove the cord from the turntable. But I'm going to try a different way here. It'll stay permanently connected. Okay, drum roll please. Clockwise. Oh, that's a weird one. It didn't work. What did I do wrong? Okay, I had the switch wired right, but apparently the output of the pulse modulated power supply has to be switched and not the input. The input has to be polarized. So this should work now. Let's try it. There we go. I wish that was a three-way switch with the middle off, but it's not, so I just have to unplug it to turn it off. Okay, I'm going to drill some holes in the platter on that weld positioner. And I made this thing several years ago. I got a video on it. It's a gear indexer. It uses a 48 tooth gear to position the chuck, and then I got a tool post drill that I'm going to drill holes in the platter with. Put some studs in my bearing cap there. It holds this little thing, which has a pin that drops into the gear teeth. And it's not perfect. This little pin's got some slop in it. I need to address that. Put a different type of pin in there. I've got the most used parts of this marked. The red dots are 6. So I'm going to, and the black dots are 4, I think. So I'm going to use the red dots and go every other red dot. And that'll give me 3 holes in my platter. And here's my tool post drill. Apparently these are available commercially. At the time that I made this, I didn't realize that, but I got a video on this too. It's a boring bar holder, but it works well. Okay, I've got my drill hooked to the tool post drill, and I can use my carriage to put force on the drill, kind of like a drill press. There we go. If I needed to, I could turn it up like that without it falling out. Probably could get away with even vertical like that. But for most things, that'll be plenty adequate. In fact, that's holding rather good. And if I've got a couple of things that I want to hold together, while I weld it, I can do that. Yeah, let's give this thing a try. Well, that was pretty good except for at the end there. And I think as it gets hotter, it needs less amps. Or possibly less speed. The less amps probably would have done it. Probably, ideally, I need to hook up my foot pedal to the amperage on my TIG welder. But I'll just have to experiment with it and get the hang of it. Coming around here, you'll see where I messed up. It got too hot. That looks good there, doesn't it? Looks really good. Yep, that's where I messed up right there, just too much amps. Well, I'm pleased with it. Overall, I think it's going to be really useful. Fairly cheap, just made it with parts on hand. Well, now for the announcement. As you just saw in that previous video clip, this cutoff tool I made is doing really well. It's almost foolproof. I won't say it's foolproof, but almost. And if you follow some basic guidelines, it works every time. I know that's hard to believe, but it does. Anyway, there's been a bunch of people ask me to make them. And how much do you charge to make me one? Well, I decided to make up a bunch of them, and I'm going to put them on my web store. So in the description area, I'll put the prices and the links to the web store. So be sure and check them out. Let's go over and take a look at the cutoff tools. Well, here's the cutoff tool. Comes complete with the cutoff tool itself, the quick change AXA holder, tool holder, and a brand new blade. Also comes with an oil bottle, which is an essential part of making this tool work. Any cutoff, this really helps. It puts the oil exactly where you need it, and it's no oil slinging, or very little. Over here I got the BXA version. Same thing, comes with the holder, the new blade, and the oil bottle. So check out the links below and check out my web store. And I've had a lot of requests for these guided tap wrenches. And I found a good deal on these right here. They're not Irwin brand, but they're probably came out of the same factory. I can't see any difference. This one here comes complete. This is my old one here. Comes complete with I put a new countersink in there. That's the guide for your wrench. And both chucks. The advantage to this one is you can take this off and use it on a ratchet, or use it on your tap handle. Here's a brand new one, same thing. And here's the new lower profile. I've got several of these made up. I like it a little better because you don't have to drop the table on your drill press so much, or not at all, hopefully. Comes with 2 wrenches, one for each size, and also complete with a new countersink. Anyway, the links are down below. Be sure and check it out. And thanks for joining me, and be sure and subscribe.